All right, well, hello everyone, and welcome back. In this video, we will introduce how to use pointers in C++. And we'll see that they're an incredibly useful tool for manipulating memory directly in our programs. All right, here's our goals for today's video. First, we'll cover why pointers and memory management are important. Then we'll explain how to declare and use pointers in C++. One of the most challenging aspects of pointers is recognizing the correct syntax and rules you need to follow. So we'll spend a good amount of time going through correct pointer syntax and making sure that you get comfortable with the different rules that govern how pointers work. So finally, to help everyone get really comfortable with pointers, we're going to do some practice programs. And you'll see that by drawing pictures and visualizing how pointers work, it can make it a lot easier to understand what's happening and predict the behavior of pointers. So let's go ahead and get started. You'll remember in our very first video, we shared that C++ has many advantages. We learned that depending on what you're trying to do, different programming languages are better at different things. And one reason why people might choose to use C++ instead of a different programming language is because C++ allows us to manage memory efficiently. And in Lecture 1, I said that we'll talk more about this later in the course. And it turns out that it's now later in the course. And, sometimes we do need to directly work with memory in order to get stuff done. So starting with today's video, we're going to learn about memory management. And then we're going to move on to object-oriented programming. So just a heads up, if you are a computer science or computer engineering major, you are going to need to use pointers all the time when you take data structures class, and very often in other classes as well. So especially if you are a computer science or computer engineering major, please make sure that you learn these pointers really well. And that way, you'll set yourself up for success in your future courses. So you'll remember that we did some discussion in Lecture 1 about C++ compared to other programming languages. And it turns out that many programming languages actually do memory management for you. For example, Java has this garbage collector that automatically cleans up memory when the memory is no longer needed. And Python uses pass by reference, and it actually does not really contain pointers. It also has some garbage collector to clean up memory. So C++ has its own set of tools, including pointers, and we'll learn about how pointers allow us to directly manage our own memory. So why should we care about pointers and memory management? There's many reasons for this. Soon we're going to be covering linked lists and data structures. And in order to work with programs that use complex linked lists and data structures, we need to know how to mess with memory. And we need to know how to manage data directly at the memory. So we'll need to know pointers for the last portions of our course. Also, for those of you interested in electrical engineering or computer engineering, memory management is really important if you are working closely with hardware. So if you're working on low-level programs like writing firmware, or building computers and computer hardware from scratch, then you probably are going to be using pointers a lot. And finally, if you plan to take any more advanced programming courses, such as data structures and algorithms, you're going to use pointers a lot. Pointers are one of the building blocks that we use in order to create data structures and more advanced types of programs. And so you'll find that in order to succeed in data structures and algorithms class, you're going to need to know pointers really well. So one other thing you might remember from the beginning of our course is that information about variables in memory. You might remember that the memory in our computer is divided into these numbered locations called bytes. And so every variable that we declare has to be stored at some location in the memory. And the location of the variable, where it lives in the memory, that is the memory address. If our variable happens to take up multiple bytes of memory, then the address will be the location of the first byte. For example, here, if I have a 3-byte block of memory, the address of that 3-byte block would be the byte containing, or the address containing the very first byte. So in this case, the location of byte 1 marks the address of that memory. So it turns out that memory addresses are extremely important, and we've actually done some memory address work already. Remember how we talked about arrays? And how when we write the name of our array, the name of the array actually stores the memory address of the 0th index. Remember, if we have like this my numbers array, then my numbers actually stores the location of my numbers element 0. And when we use an array in the functions, the memory address is actually plugged into the function so that the function knows where to go and find our array. So the name of the array actually only stores the memory address of the very first item, or element 0. Another place where we have already used memory addresses is when using call by reference or pass by reference. Remember, in call by reference or pass by reference, you're actually plugging in the memory address where that variable lives into the function. And so that is why functions can directly change their own arguments, because they have permission to go straight into the memory and change it. And that's why we use those ampersands in call by reference. The ampersand allows us to pass the memory address of the variable into the function as an argument. And since we are plugging in the memory address of that variable, that function can directly change the data, and the changes will be preserved even back in the main function. So that brings us to today's video. We've talked about how it's important to be able to manage memory, and to do that, we use something called a pointer. A pointer is a data type that specifically stores a memory address. And so we call it a pointer because it actually just directly points to some location in the memory. It's a variable holding the memory address where some value is stored. And so depending on the memory address in the pointer, we could be storing the address of an int, or a double, or something else completely. So let's take a look at how we can actually declare and use pointers in our programs. There's a lot of special details about syntax and a lot of important things to remember when working with pointers. So to help, I've broken pointers down into several sets of rules. So what we'll do in this video is we'll review each list of rules about pointers. We'll go through these rules one by one, and we'll talk through some examples and practice programs demonstrating each rule. Then at the end of the video, we'll look at some examples where we put all these rules together. So I highly recommend, as you start getting comfortable with pointers, consider writing these rules down and keeping them in a convenient location so you can easily reference them. You'll find once you get familiar with these rules and get comfortable using them, pointers are actually incredibly straightforward. But it's very important that you take the time to understand these rules and how pointers work. Let's go through these rules one by one. We'll go through the list here, and then we'll go in greater detail in the next slides. First rule of pointers is that you need to use the reference operator, or the ampersand, to get the memory address of a variable. For example, if I want to get the memory address of my variable num, I could use a cout statement and say cout ampersand num. That would output the memory address where num is stored to the screen. If I want to declare a pointer variable, I need to use an asterisk. So you'll see here, for example, if I want to declare two pointers, ptr1 and ptr2, I have to write int star ptr1 star ptr2. And that asterisk is what designates that value as a pointer. Notice that the spacing between the asterisk and the name ptr does not matter. Some people will do int star ptr. Some people will do int star ptr. Either is acceptable. Next is rule number 3. You can't mix different data types with pointers. So whatever you declare your pointer as, that pointer can only store memory addresses of its given type. So int pointers, or int type pointers, can only hold int addresses, and so on. Double type pointers can only hold double type addresses, and so on. So you have to make sure you're careful when declaring your pointers. You don't want to mix different data types. Rule number 4. Generally, you want to make sure you always initialize your pointer to hold a given memory address, or the null pointer, which is memory address 0. And finally, rule number 5. You want to make sure that you sound professional and knowledgeable when discussing pointers, and it turns out there is some correct wording that you want to use. You want to avoid sounding like what we call a noob programmer. So let's go through these rules in a little bit more detail. First rule, use the ampersand to get a variable's memory address. As we mentioned, this address operator, or ampersand, will return the memory address of whatever variable that you put it next to. So for example, if I have this int variable num, If I say cout ampersand num, that will output the memory address where num lives. If I want to declare a pointer and make that pointer hold the address of num, I can write int star ptr equals ampersand num. This will declare a pointer ptr and initialize it to store num's memory address. So we'll use the ampersand a lot when we are initializing our pointers to point at different things. Next, suppose we want to actually declare pointers. As we mentioned, what you need to do is you need to take the type that the pointer should be, like int type, double type, cat type, whatever type your pointer is, and then you take an asterisk and you put the variable's name. The asterisk can actually be next to type name or next to the variable name. Remember, the spacing does not matter, but you must have an asterisk in front of the name for each pointer variable. For example, here, to declare a pointer variable named ptr1, I write int asterisk ptr1. This is read as ptr1 holds a memory address for a type int. If I want to declare two double type pointers, I can say double asterisk pointer1 asterisk pointer2. Each of these, pointer1 and pointer2, will be able to hold a single memory address of type double. So what happens when we declare a pointer in the memory? So if we take a look at this code that we looked at earlier, here I've declared an int type pointer named ptr. ptr can store the memory address of an int variable. So here, for example, is our int ptr, and notice if I say ptr equals ampersand num, then what I'm doing is I'm storing num's memory address in my variable ptr. And if I were to go into the memory at address 0x4a00, this is num's memory address, notice that I would find the value 25 stored in the memory address. So notice that the pointer ptr does not hold the value 25. ptr points to the location where num is stored. So ptr holds the location where num is stored, not the actual value of num. So remember, pointers hold memory addresses, or locations in the memory. One other point, remember that spacing between the asterisk and the pointer variable name doesn't matter. So you could actually have the asterisk in any one of those places, and it would still be perfectly acceptable. And remember, you do need to include an asterisk next to each pointer variable when you declare it. So example here, you'll notice if I say int asterisk num1 asterisk num2, these are both declare it as pointer type. But notice v1 and v2, those are going to be regular ints because they don't have an asterisk next to the name. So if you want to declare pointer variables, make sure you include the asterisk next to each name when you declare it. Let's go ahead and try a quick practice question. Suppose we want to declare pointer variables for two int type variables. So we want a pointer named num1 and a pointer named num2. Which of these would be the correct way to declare that pointer variable? Take a moment and see if you can identify the correct answer. What did everyone come up with? Correct answer here is choice B. Remember, you need to have the asterisk next to the name of each pointer type variable. So if I want two int type pointers, I need to put an asterisk next to both num1 and num2. All right, our next rule, you'll remember we mentioned that we want to initialize our pointers. And since pointers hold memory addresses, we initialize a pointer by assigning it a memory address. So often we can give our pointer a memory address right away using the ampersand. But if we don't immediately have an address for our pointer to point at, it's a good practice to initialize your pointer to null. For example, here we can say int ptr points to null pointer. This will actually initialize ptr to hold the null memory address. So usually we just write it as null pointer, nullptr, and that is basically memory address 0. Notice you can also do things like testing for invalid memory addresses with the not operator. But generally, you need to make sure you initialize your pointers because otherwise, like any other variable, they'll just contain random data if they're not initialized by you. Next point. You'll remember in our rules we mentioned that you cannot mix data types with pointers. So pointers can only hold memory addresses of their own data type. So int pointers can hold int memory addresses, double pointers can hold double memory addresses, and so on. For example, here if I had a double type variable and I tried to store its address in an int pointer, that won't work. I can only store int memory addresses inside an int pointer. So the last point before we move on, let's just remind everybody about correct wording to describe pointers. This might seem a little silly, but it actually is a thing. And so you want to try to use the correct wording when you talk about pointers. This helps you avoid sounding like what we would call a noob programmer or an inexperienced programmer. And when talking about pointers, we usually talk about pointers as actual pointers themselves rather than addresses. So for example, if I have num1 equals ampersand v1, we don't usually say num1 equals ampersand v1. Instead, we say num1 points to v1. Or the pointer num1 points to the variable v1. This is a very subtle thing, but if you get in the habit of using the more articulate language, then it will make you sound like a more experienced programmer and hopefully also help you understand what each line of code is doing. So do the best you can to try to use this more precise language when talking about pointers. Let's try another practice question. Here we're being asked, what will this code output? We are told to assume that myInt variable is being stored at memory address 0380FED4. So take a moment and see if you can correctly identify what the output will be. So notice what's going on in this program. We've declared something called myInt variable. This is just an int value. So I've declared some variable named myInt variable, and I've assigned it the value 99. I've also, in the second line of code, declared something called myInt variables pointer. And notice I have given myInt variables pointer, I've assigned it the value of myInt variables memory address. That means myInt variables pointer is pointing at myInt variable. So in this case, myInt variables pointer holds the memory address where myInt variable is located. And if I were to go in the memory and search for myInt variable, I would find the value 99 stored at that memory address. So this program is asking us, what will be the output of this code? Well, we have one cout statement that is outputting myInt variable, and the second cout statement, or the second item in that cout statement, is myInt variables pointer. All right, well, if I say cout myInt variable, that's going to output whatever's stored inside myInt variable to the screen. MyInt variable currently contains the value 99. If I say cout myInt variables pointer, that is going to output the value stored inside myInt variables pointer. MyInt variables pointer is holding the memory address where myInt variable is located. So if I output the name of my pointer to the screen, it's going to output the memory address that it's currently holding. So the correct answer for this question is actually choice A. We will first output the value stored in myInt variable, then we have a space, and then we are outputting the memory address stored inside myInt variables pointer. You'll see I drew some pictures here to help keep track of what is happening, and if it helps, I highly recommend that you do the same. You'll see that in some of our assignments and in our examples in future videos, I will actually require that you draw pictures to help visualize what the pointers are doing. So definitely don't be afraid to draw pictures if you need, and you'll see soon it will actually be required for some of our assignments. So once again, the answer to our question, we saw that if we output the name of a variable, that's just going to output the value stored in that variable. And remember, if we output the name of pointer to the screen, that is going to give us the memory address stored inside that pointer. So in this case, we received the location where my int variable is stored. So feel free to reach out if you have any questions on these first rules, and keep them handy. It's really helpful to have the rules of pointers in front of you as you start getting familiar writing programs with pointers. Let's now cover a few more rules about using pointers in programs. Let's continue with rule number 6. We covered rules 1 through 5, and so now 6 is getting a little bit more fancy. Rule number 6 says that if we use the asterisk and a pointer variable's name, that will return the value of whatever we are pointing at. So for example, if I have a pointer ptr1, maybe it's storing the memory address of num. So if ptr1 is pointing at num in the memory, say num holds the value 99. If ptr1 is pointing at num, then if I write asterisk ptr1, that will return the value I'm pointing at, which here, asterisk ptr1, that would return 99. Since ptr1 is pointing at num, and num is currently initialized to 99. Next rule. Using the assignment operator, or the equal sign, that changes the pointer's memory address, and that changes where the pointer points. So assigning a pointer a new memory address will change where the pointer points, but it will not change the value of the data stored in the memory. So we can change where our pointer points without affecting the values we are pointing at. Rule number 8. Using our assignment operator and asterisk together directly changes the value that our pointer is pointing to. Let's consider the example that we talked about a moment ago. Suppose I have my pointer ptr, and it's currently pointing at num in the memory. If I were to write the code asterisk ptr equals 5, that basically says go where ptr points and assign that memory the value 5. So notice using the assignment operator and asterisk directly will actually allow us to change the memory where our pointer points. So we can actually directly change this variable num and change it from 99 to 5. Finally, last rule, we can use the new operator to create a new variable at a specific location in memory. We'll cover more examples of that in just a moment. Let's go through these rules in detail, one by one, and do a few more examples. All right, first new rule. Use the asterisk to return the value of what we are pointing at. Notice that we used the asterisk to declare pointers, for example, int asterisk my int variable's pointer. But the asterisk can also be used to return the value of what we are pointing at. So for example, here if I have my int variable, which I have initialized to contain the number 99, and if I have my int variable's pointer, which is currently holding the memory address of my int variable, we can say that my int variable's pointer is pointing at my int variable. So if I write cout my int variable, that's going to return the value 99. Cout my int variable's pointer, that's going to return the memory address that we're pointing at. But notice if I write cout asterisk my int variable's pointer, this will return 99 because my int variable's pointer is pointing at the memory which holds 99. So basically, we're returning the value that we are pointing at. So if we want to return the actual value stored in the memory where we're pointing, we can use asterisk and the pointer's name. So it turns out there's a special name for this. If we use the asterisk to output the value where a pointer points, that is called the dereferencing operator. So asterisk allows you to access the data that your pointer is pointing to. And whatever variable that we use the asterisk on, that is called being dereferenced. For example, if I write cout asterisk my pointer, and suppose my pointer, maybe my pointer is pointing at some variable num, maybe num contains the value 10, cout asterisk my pointer will return 10, or output 10 to the screen. And here, asterisk is being used as a dereferencing operator. We say that my pointer is the thing being dereferenced. So basically we're saying, okay, go where my pointer points and tell me what value is stored there. So it turns out that using this dereferencing operator, it gives us an alternative method for outputting the value of a variable or the value stored in the memory. Up to this point in the class, we've been doing kind of this usual way where we use cout and the variable's name. But another way we can access the data in that memory is to use cout and the name of a pointer which points at that data. So if we say cout asterisk my int variable's pointer, that's going to return the value that our pointer was pointing at. Let's go ahead and try another practice. Suppose I have the code shown here. So notice I have an int variable called myVariable. And suppose myVariable is initialized to 9,999. I've also declared my pointer, which is an int type pointer, and notice I've initialized it to point at my int variable. So this question is asking, which of these is the correct way to output the value held in my variable? So we want to output 9,999, but we want to output that value using my pointer. Which of the following cout statements is correct? Take a moment and see if you can identify it. All right, what did everyone get? Well, choice D is flat out wrong syntax. Choice A, cout my pointer, this will actually output my int variable, because that's the value stored in my pointer. So choice A is not quite correct. Cout ampersand my pointer, that will output the memory address where the pointer is stored, or where the pointer variable itself is located. That's also not correct. We don't care about the memory address where this pointer lives. It doesn't matter where this pointer is stored in memory. What we want to access is we want to access 9,999. To do that, we use choice B. We write cout asterisk my pointer. Asterisk tells us, go where my pointer is pointing and return the value stored there. So here, asterisk my pointer is going to go to the memory where I'm pointing, which is my variable, and it's going to return the value 9,999. Let's try another practice question. Suppose I have this code shown here, where I'm declaring two variables. And then I have two pointers. I set one pointer equal to the other, and then I have an output. Take a moment and see if you can figure out what this code will output. Meanwhile, I'm going to draw some pictures. So notice what I have in this program. I declare variable 1, and I initialize it to contain the value 4. I also declare int var1 pointer, and I initialize it to hold the memory address of variable 1. Similarly, I take my variable 2 and I assign it the value 2, and I initialize variable 2 pointer to point at the memory address of variable 2. But then this happens. What happens if we assign variable 2 pointer the value in variable 1 pointer? Well, let's see what happens. Variable 1 pointer is holding the memory address of variable 1. So if I also give variable 2 pointer that same address, that means variable 2 pointer will now point variable 2 pointer will now point to variable 1. So if variable 2 pointer now points to variable 1 up here, what's going to happen if I write cout asterisk variable 2 pointer? Well, asterisk variable 2 pointer means go where variable 2 pointer is pointing and output return the data stored there. So cout asterisk variable 2 pointer, that's going to go where variable 2 pointer points, and it's going to return the value 4. So in this case, because we first made variable 2 pointer point where variable 1 pointer points, we actually outputted variable 1 to the screen. So the key takeaway here is to be careful when you're using the equal sign with pointers. Remember, single equal is the assignment operator, and that's used to assign value. So you certainly can use the assignment operator to assign value, but remember, it will cause your pointer variables to point at a new location. And remember that the assignment operator will change the memory address where we point, but it will not affect the value stored in the memory. It's only going to change the address where our pointer points. Let's try another practice question. Once again, we have variable 1, variable 2, and the pointers variable 1 pointer and variable 2 pointer. But now, look what I did. I'm writing asterisk variable 2 pointer equals asterisk variable 1 pointer. Question here is, what will that cout statement output? Take a moment and think about it, and try drawing some pictures. So in this case, once again, we start our program by declaring and initializing variable 1. So variable 1 is assigned the value 4, and variable 1 pointer is assigned the memory address of variable 1. Similarly, variable 2 pointer is assigned the value 2. Variable 2 is assigned the value 2, and variable 2 pointer is made to point at variable 2. So this is our initial condition. What is going to happen here? Well, notice what asterisk variable 1 pointer does. This tells us to go where variable 1 pointer points and return the value stored there. Then, asterisk variable 2 pointer equals 4. That is going to go where variable 2 pointer points, and this is going to change variable 2 such that variable 2 pointer is now pointing at the number 4. So correct answer here, our cout statement is actually going to output 2 4s because we have used variable 2 pointer and the asterisk to change variable 2 to now hold the value 4. This brings up a really important point. You need to be very careful when using the assignment operator and the asterisk with pointer variables. This can be an incredibly useful tool, but you got to be careful because this will actually allow one pointer to change data. And writing asterisk variable 2 pointer equals asterisk variable 1 pointer, that's the same thing as setting our two variables to be equal to each other because we made variable 2's data the same as what was stored where variable 1 points. So it's an important tool, but you got to be careful that you use it very, very intentionally, and you don't want to accidentally create errors. So just to emphasize, once again, when we're using the assignment operator and asterisk together, we are directly changing the values that our pointer points to. For example, if I do something like this, where I say ptr1 equals &num, ptr2 points to the memory address num1 and num2 like this. So notice, if I have ptr1 pointing at memory address of num1, ptr2 pointing at memory address of num2, if I say ptr1 equals ptr2, then that will make ptr1 hold the same memory address as ptr2. So both of these will now point at the same thing. Instead, if I say asterisk ptr1 equals asterisk ptr2, if we assign some values, basically what that means is go where ptr1 points and change that data to hold the same thing as the data which ptr2 points at. So here, asterisk ptr2 is pointing at the number 20. So in this case, if I write asterisk ptr1 equals asterisk ptr2, then notice ptr1 will now point at the number 20 as well. So num1 will be changed to hold the same thing as num2. So this is a really important point, and this comes up a lot. So please make sure you understand the differences between using assignment and asterisk versus just assignment alone. Finally, the last rule that we covered was about the new operator. And the new operator will basically return the memory address of a block of memory big enough to hold a variable. And this variable will be a little bit special. It will actually be able to produce what's called a dynamic variable. And we'll cover this more in the next video. Here's an example. Suppose I have a pointer p1. So this is just a pointer. If I say p1 points to a new int, basically we're just finding a block of memory big enough to hold an int and we're giving P1 that memory address. So we're making P1 point at some new integer-sized memory address in our memory. So this new operator might seem kind of silly, like when would we want to use that? It turns out that these dynamic variables are the building blocks for fancy data structures. And we'll learn more about these towards the end of the course. Here's a quick example of the new operator. So you can see here we declared a pointer P1, initialized P1 to point at a new int. And so basically what this code is doing is we have that pointer P1, and it's pointing to some new int. And notice that this new int does not have a name. It's just a bit of memory that the pointer's pointing at. But I can actually prompt the user to give me a value. And here I could, if I received, for example, the value 99, notice I can use the dereferencing operator, or asterisk, to copy the user's input and store it where P1 points. So we'll take a closer look at the new operator and these dynamic variables in our next video. Finally, before we end for today, I'd like to go through some extra examples to help everybody practice pointers. So I highly recommend, as we go through this example, draw pictures to keep track of what is happening. And note that I will ask similar questions as this on quizzes and exams, and on our next assignment. So let's see how we could do that in this short sample program. Here I've declared two pointers of int type, P1 and P2. So essentially what's happening here is I've declared a pointer P1 and another pointer P2. Then in the next line of code, notice I make P1 point to a new int, and I wrote asterisk P1 equals 2. So that's going to initialize P1's data, or the data where P1 points, to 2. So that's the result for the first few lines of our code. Let's look at what happens next. So now I have my pointer P2, and I have made P2 point where P1 points. Because remember, if I set my pointer P2 to hold P1's memory address, now both P1 and P2 are pointing at my new int. So this cout statement would actually output it's actually going to output 2 for both outputs because both P1 and P2 are pointing at 2. Look what happens next. We have asterisk P2 equals 3. Notice that asterisk P2 equals 3. That means I'm going to go where P2 points. And now P2's memory holds the value 3. So both P1 and P2 are now pointing at 3. So both of these cout statements will output 3 because both P1 and P2 are pointing at 3. Finally, in our last line of code, we have P1 points to a new int, and we dereference P1 to 4. So when we do that, notice P1 is now going to point somewhere else, but P2 is still pointing at our other new int that held the value 3. So notice now P1 and P2 each have their own thing, but now P1 is pointing to a new int that's holding the value 4, and P2 is pointing to some new int that still holds the value 3. So this asterisk P1 should output the number 4, but asterisk P2 is going to output the value 3. So this is a really good practice to make sure you understand the different types of syntax and the different operations we can perform using pointers. And if you were to go ahead and run this program, you can see the output is exactly what we had predicted. We see that for our first cout statements, both P1 and P2 were pointing at 2. For our second set of cout statements, we had changed the memory and updated it to now hold the value 3. So P1, P2 were pointing at 3. But then finally we gave P1 its own private new int. And so after doing that, we see that P1 and P2 are now pointing at different values. So the value stored in P1's memory was 4, but value stored where P2 points was 3. So I highly recommend going back through these examples yourself and verifying that you really understand how this syntax works. So finally, before we end, I would like to share one last practice question, and this is actually very similar to our pointer assignment. So in our pointer assignment, you will be required to draw pictures. You're going to be required to draw pictures in a similar way to practice and understand pointers. So please refer to this example question as a guide when you're working on our pointer assignment, because you'll see that I'm going to be asking very similar types of questions. And I guarantee you that on our next exam, and definitely on our final exam, there's going to be a very similar question. So you'll want to make sure you really understand how to solve these pointer questions and how to draw pictures to track what's going on in the memory. So let's go ahead and walk through this pointer question. And I would encourage you to follow along on paper as we go through it. So here's an example of a pointer question which I might ask on an assignment or on an exam. Here we're given some initial information about where our variables are stored, and we are also given some code. So when tracking memory, I like to use the pictures like this. So if I have a variable, I would write the variable's name, and then I draw a box. On top of the box, I write the variable's address, or the variable's memory address. And then inside the box, I write the variable's value. And then if I have a pointer pointing at that variable, then I can also have a pointer holding the same variable's memory address, and I can use arrows to show where our pointers point. So I encourage you to use the following strategy for solving pointer problems. First, you want to make sure you draw all the variables and label the values and memory addresses either using my convention above or another that makes sense to you. And then you can read through the program and update your pictures to track what is happening. And finally, remember to refer to our pointer rules to remember the use of the asterisk operator, equal sign, and other key operations. So with this strategy in mind, let's go ahead and try solving the pointer question shown here. So if I were to solve this question on a homework assignment or an exam, this is how I would do it. Notice I'm given a lot of information about A, B, C, D, E in the beginning of the problem. So I'm going to go ahead and make an area in my workspace here. This is my main function. And in my main function, I know that my variables A, B, C, D, and E are declared inside main. So following my naming convention, I'm going to make my variable a, give a box where I can put the value. And a is stored at memory address 1000, so I write my variable a like this. Similarly, my variable b is stored at address 2000. Variable c is stored at address 3000. Variable d is stored at address 4000. Oops. So notice I'm just putting the memory address for that variable on top. Since d is a pointer, I'm also going to put a little asterisk next to it, just so I remember that d is a pointer rather than a regular int. And finally, my variable e, also a pointer. E is stored at memory address 5000. So I went ahead and, since I know that this memory is all being allocated by main, I went ahead and drew those boxes. Now that I have drawn the boxes to hold my variables a through e, I'm going to start reading through this program line by line, and I'm going to update my drawings. As I read the program line by line. It can often be helpful to use different colors while doing this, so consider having different colors available. First line of code, I say int a equals 2. So I go to my a variable and I assign it the value 2 inside its box. Int b equals 60, so I go to my variable b inside my memory and I give it the value 60. Int c is 200, so I give c the value 200. Look what happens with d, though. D is a pointer. And I'm declaring my pointer d, but I'm making it point at a new int. I am told memory allocated on the heap using new will be stored at address 8000. Remember, since d is a pointer, d is going to hold the memory address 8000 where the new int was created. So notice here, my pointer d is going to be pointing to that new int. Asterisk d equals a. Well, notice what this line of code will do. I'm going to go where my pointer d points. That's this new int. And I'm going to assign that the value stored in a. So here, I'm going to assign d's new int the value stored in a, which is 2. Finally, int star e equals ampersand b. Remember, that's the same thing as declaring our pointer e and making it point at the memory address of b. Essentially, what we're doing here is we're taking e and making it point at memory address b. That also means that our pointer e is going to store b's memory address. So e is now holding b's memory address and pointing at our variable b. All right, in the next line of code, we are calling the function mystery. So notice mystery is the function shown here above our main function. Remember, we do not actually run the code in mystery until it is called. But here, we're going to go ahead, and since we've called mystery, we're going to exit our main function and enter mystery. So when we're inside the mystery function is going to have its own variables, A, B, and C. So notice the variables A, B, and C are local to mystery. And notice that D is going to be plugged in for A, C is going to be plugged in for B, and my variable B in main is being passed by reference into C. So let's update my mystery variables A, which is a pointer, B, and C, with the values that we passed in when calling mystery. So notice in main, my variable D was a pointer that held the memory address 8000. So that means in my mystery function, I'm going to plug in D for my variable A. So I'm going to copy my value 8000. And now my pointer A is also going to point at memory address 8000 where D points. Because remember, both A and D are pointers, and they both are holding the memory address 8000. So since I plugged in D's value 8000 into mystery, that is how we both point at that new int 2. The next value we substitute into mystery is the value C in main, our variable C. So in this case, C is just an int. So we're plugging in our variable C in main into our variable B in mystery. So we take the 200 stored in C and we plug it in to the 200 in mystery, or to variable B in mystery. Finally, this last one is very important. I'll use a slightly different color here just to illustrate what's happening. Notice that this variable B in main is being passed by reference into mystery's variable C. So what I'm going to do here is I'm going to put a note so I remember that this is pass by reference. Oops, and I drew the arrow incorrectly. Notice I'm plugging in my variable B in main into mystery as variable C. So mystery is going to receive that variable 60, but any changes made to C by mystery will also change C, or I'm sorry, variable B in main due to pass by reference. So it's helpful to note that in your picture so that you remember. So when I call that mystery function, I'm exiting main, entering mystery, and I have plugged in A, B, and C into my mystery function. I can now run the code inside Mystery and track what happens in my Mystery function. First line of code is C++. That is the same as writing C equals C plus 1. So that means this variable C is going to be incremented to 61. But because it's passed by reference, variable B back in main is also going to be incremented to 61. Next line of code, we have B minus minus. So that's 200 equals 200 minus 1. So our variable B is going to be decremented to 199. Next, asterisk A equals 3. So remember what that means is I'm going to go where A points. So I'm going to go where pointer A points and update that value to be 3. So because my pointer A was pointing at memory address 8000 back in main, that pointer A can go in and change my data inside main to store the value 3. Now I have a cout statement. I'm being asked to output the address stored in A, which is the A in Mystery. So I'm sorry, not the address stored in A. I'm supposed to output the value where Mystery's A points. Mystery's A is pointing at 3. Next, I'm outputting Mystery's variable B. B contains the value 199. Finally, I need to output my variable C. C inside Mystery contains the value 61. Finally, Mystery is going to return the value where A points, which is 3. But I don't give Mystery any variable to return A to, so that return value is just going to be thrown away. No one is there in main to receive it. Finally, at the end of my program, I have some additional cout statements. Notice now the variables I'm outputting in this set of cout statements are the variables local to main instead of the variables that were in Mystery. So here if I output A to the screen, that will output the value 2. If I output B to the screen, that's going to output 61. Remember, because of pass by reference, changes made by Mystery still affected the changes in B. Or the changes made by Mystery still caused B and main to be changed. If I output C to the screen, I'm just going to output that number 200. And if I output D, notice D is a pointer. So if I output whatever's stored in D, that's going to be the memory address, 8000. And if I output E to the screen, E is another pointer. And remember, E is holding the memory address where B lives, so E will output the memory address 2000. Last line of cout statements, we have cout ampersand A. That's the memory address where A lives. That will give us 1000. Ampersand B, that's the memory address of B. That's 2000. Ampersand C is memory address of C, which is 3000. Asterisk D, remember, that is the value that D is pointing at. D is pointing at the number 3. And our pointer E, asterisk E, means to return the value that E points at. E is pointing at our variable B, which holds the number 61. So asterisk E will output 61 to the screen. So there you have it. You can see that these drawing problems might have a lot of steps and a lot of things to keep track of, but they're really great practice to make sure you truly understand how pointers work. So please make sure you take the time to go through this example on your own and verify that you can get the same result that I did. I guarantee there's going to be a question like this on our final exam and on future assignments and quizzes. So you really want to make sure you understand this. And please use our upcoming assignment to help you practice some similar questions. So make sure, whenever you see a question like this, draw pictures. You're going to be required to turn in your pictures when you submit your assignments. So make sure you draw pictures to keep track of what's happening. Alright, so let's wrap up here for today. I hope you found this video helpful as an overview of pointers and as an introduction to how to use pointers in C++. You should now be able to explain why pointers and memory management are important in programming. And you should now know how to declare and use pointers in C++. Please be careful to remember the pointer rules, and be sure to follow correct pointer syntax and pointer rules as you work on programs. Finally, I highly recommend that you draw pictures to really visualize how pointers work in C++. Please use the examples, especially the last example we did, to really practice and make sure you understand how pointers work. In our next video, we'll take a closer look at dynamic memory and how pointers can be used to do useful and interesting things in our programs. So thanks everyone for joining the fun. Feel free to reach out if you have questions, and we'll see you in the next video.